Hello guys, my name is Arun and welcome to my channel. This series is a series of tutorials on Advanced Fortran programming. Now, this tutorial we'll be looking at how to interface subroutines. Now, this will be a very short one. This program will be this function. Okay, I'm messing up things here. Okay, this video will be the extension of the previous tutorial, wherein we saw how to interface functions. Here it will be like interfacing subroutines. Now what I've done here is that okay, let me write on the top here. Swapping of variables is used for subroutine interfacing. Okay, is used for function interfacing. Okay, now as the comment mentions here, for explaining subroutine interfacing I'm using swapping of variables. So what I have here is I have two subroutines, swap underscore. Okay, it's not fitting in the screen properly. Okay, let me just lower this down. Perfect. Now I have here is that I have two subroutines, swap underscore int and swap underscore real. Both of them does the exact same job. They take two variables a and b under the pretext in out. Okay, this function is integer. I have a temporary local for subroutine variable c, and I have a local subroutine variable c which is real here, and whereas the incoming variables are in out and type real, and then I'm using c to swap the variables out and swap the values. Simple as that. Okay, now how do we interface this? Again the interfacing is quite simple. Okay, what I done here is that exactly following the same method as above. What I did here is that in the same function, in the same program, I have written a new interface called as swap. Okay, and then inside this interface I have written the subroutine name swap underscore real with its variables and its data definition here, and similarly I've ended here, and similarly I've written the swap underscore ints data definition here, and I ended here, and all the data definitions alone are kept in. Now see, if you notice this, the swapping subroutine has another line called as integer c and real c. Here it's real c. These two variables are local to the function. Okay, sorry, local to the subroutine. So sometimes what happened is that if you don't include them, again I tested this program. When I included this line, it worked nice. Even if I did not include it, it worked nice. So the point here is, for functions, subroutines, all the variables which are in the input and output processing, they have to be included, which I kind of figured out. But even if you include the local variables inside, it doesn't matter. So as a rule of thumb, or for safety precaution, you can include the other temporary variables defined in the subroutine or function as per your wish. But my point is, if the compiler is not throwing any error, and if it's working fine, do not include it. And if it's throwing an error saying that certain variable is missing or something of that sort, include that. Fine, fair enough. Now with this, the interfacing in this block of code, the interfacing is done. Now let me explain the variable that I've used over here. Simple as that. I included two variables, SIA and SIB, to include swapping of integers. That's what SI stands for, and SR stands for swapping of real numbers, and A and B are just two values which has 4 and 5 values to it, and then two real values, SRA equals 4 and SRB equals 5. Now what I've done here is that after the geoterm and the swapping interfaces, the swapping functions begin over here, and I'm just mentioning integer swapping, and before swapping I'm printing the variables, and I'm calling the subroutine function. I'm calling the subroutine using the call, and the name, if you guys notice, it is just swap, which is nothing but the interface's name. Okay, so like I said in the previous tutorial, okay, whenever interface name is called, it looks at the data type of the variables that are plugged into it. plugged into it, and based on the data types, it compares the subroutine which has the closest, which has the same exact data type as that of the values that are passed in, and then calls the subroutine accordingly. Here what it does is, since these two are integers, it compares the subroutines as to which data types have the integers, and this will be ruled out because both of them are reals, and this will be included because both of them are integers, and this subroutine is called for. And when this is called, all the definition which are defined on the top according to it will be run. Okay, now with that, in this line, integer swap underscore int will be called under the hood, and after that the swapping values will be swapped, and we will just printing over here to get the values. Similarly, float swapping, I start the float swapping. Before that, I'm just printing the values of A and B, SRA and SRB here before the swapping, and then I'm using the same subroutine call as I done on the top over here, okay, to invoke the swap underscore real subroutine to get the values, to swap the values. Fair enough, and that's as simple as that. Now with this, the subroutine swapping is demonstrated. Now what we'll do, we'll just to visualize this clearly, let's run this out, compile, building, and running this. Okay, now if I were to push this here, okay, from here to here, just the previous tutorials results which I have included in the function on the top, which means in the program on the top, so that's not of interest right now. Okay, this is where of interest. Now here it calls the integer swapping function, this line over here, and then it just prints the values SIA equals B4 and SIB equals 5, just like the values over here. It prints over there, and if you guys notice, the swap function is called after this, and then swapping is done and the values are printed accordingly. If you see, the values are interchanged. Similarly, float swapping is done, and then I get the values here and I swap it and they are printed over here, and that's it. The subroutines have been called nicely. Okay, now let's do a little troubleshooting. Let's make a little changes to this code and see what happens here. Now, since I've included these parts which are temporary variables here, I mean local variables inside the subroutine, do you think we'll have an error? Let's see. No. When I compile and build and execute this, sorry, you have no error. So this is again a quick check to know whether we have to include the local variables or not. Even if included, I think it won't be a problem, so it's not an issue over here. Okay, now let's do a little real mischief to see how this interfacing works like. Now what I do is that I just make this as GAO and make this as AR. Okay, if you guys notice, sorry, GAO, and this I'll let it be AAO and this be GR. Now if you guys notice, I am intentionally changing the data types of these functions over here. Okay, now if I were to compile this, okay, I'm not sure whether you get the issue or not. It just throws me a lot of errors. It just says that there is no specific function for generic geo underscore term. Okay, meaning what it means is that see, this is real and this is an integer. Okay, now if you look at the interface definition, this function is fully integer. This function is fully real in all the major input variables. Okay, except for the n. Okay, that you have to ignore the n for now. Other than that, this is fully integer, this is fully real, and there is no mix and match. Okay, suppose if we had a function wherein this is mix and matched, and that will be called, and since that mix and matching is not present, it is throwing an error. So it will throw an error, and that other than that, it's fine. Now if I rectify this, if I were to compile this, if you guys notice, now it's fine. It compiled nicely, and build this and execute this, and it works out fine. So this is the integration. So this way This way, suppose if you want to play with a different type of if you just want to play with a different type of value data types, and you want to call a different interface functions of the different types, it's perfectly possible. Similarly, although this is not the only thing that can be done, I can do something else to it also. Now what I've done here, now you can do some specific function also. Now what I mean here is, because of this interfacing function, that does not mean these functions have to be ideal. These have to be replicas of each other. They can have their own set of values into it. I mean, they can have their own set of definitions instead of being perfect clones of each other. Okay, so what I mean by that is, watch. Now what I've done here is, now let me say let me include a value. Since this is real, now AC. Okay, AC, fine. Now what I've done here, what will I do here is that AC equals 2 times AN, okay, and then what I do is that AN will be equal to 0.5 times AC. Okay, and now if you guys notice, these two steps are not at all necessary, but they'll be worked nicely. So if I were to print AC here, print AC equals comma AC, now if you guys notice, this will be printed. Now because of this, now this function is not exactly the same as this function. Yes, now if I were to swap the variable, now if I were to use them accordingly, okay, now this will give another indication of how the swapping done. Now if I done this, now let's see what it turns out to be. If I were to compile this, no error, build this, no error. If I were to execute this, okay, now see, we're getting this value over here, which is quite interesting, because the function value the function value has been invoked here. So this way, when we use an interface function, we get to know that you don't have to keep exactly similar same functions. Okay, the same functions, they can be of different functions, and they can do so this way you can club multiple functions under the same interfacing. But the only thing that matters is that not the name, but the correspondence with the data types of the input and output variables. Okay, now if those are mentioned, I can multiply thousands of functions inside it, and by matching the criteria. Suppose if I were to create another function which takes the same variables, and does a similar set of jobs, as long as the data types are similar, I can get a different set of operations done on it. Okay, using a different function name, and then using the interface, I can, based on the data type, I can use the same interface name. Okay, hope you guys understood this, and if you guys do not understand, I mean, just have a look at this again. I think you'll be fine. Okay, and as mentioned in the previous tutorial, we have one more topic to cover in interfacing of functions and subroutines. In fact, interfacing of functions subroutines. That topic is nothing but interfacing functions and subroutines which are part of a procedure, which are part of a module. Okay, that will be done in the next tutorial, and after that we will be looking at defining operators. We'll be looking at defining operators using interface functions, interface facilities. Okay, and we'll also, if possible, we look at overloading of operators to see how that can be done and all. Okay, that's all I have for you guys in this tutorial. Thank you guys for watching, and I'll see you guys next tutorial. So bye.